Current electricity numerical problems. So page number 229 of your textbook. Question 10, a battery of EMF 4 volt. So we have been given the first EMF is 4 volt and internal resistance 1 ohm is connected in parallel with another battery of EMF 1 volt and internal resistance 1 ohm. So there are two EMFs. So I'll write the first EMF as E1. Let us assume the first EMF that I'm considering will be E1, that is of 4 volt. So E1 is 4 volt. E2 is 1 volt. Internal resistance small r is denoted for internal resistance. Small r is 1 ohm for first battery. For second battery also it is 1 ohm. Are connected in parallel combination. They are told they are connected in parallel. The combination is used to send a current through an external resistance. External resistance is always denoted by capital R, that is 2 ohm. Calculate the current I. Whenever there are cells in parallel, for cells in parallel, the current I is equal to E equivalent upon R plus R equivalent. This is an 11th standard formula. There is an alternative method to solve this question. Alternative method is to use Kirchhoff law. You can construct a diagram. In many books also you will find the solution for this uh, solution for this question as to draw Kirchhoff, to draw first a circuit diagram, then use Kirchhoff law to solve. Even in our textbook, if you find there is a similar sum, example 9.2 in our textbook, example number 9.2 in our textbook for this chapter. If you see, so they have used the same type of sum. The values are changed. The question is same. They have solved the same type of sum using Kirchhoff law. I am using some alternative method. You can surely use this method in board exam also, because in the question there is nowhere mentioned that you need to use Kirchhoff law compulsorily. If that was the case, so you should have compulsorily used Kirchhoff law. The question nowhere says that you should use Kirchhoff law to find the answer. As the question does not say, there is an alternative method which I am using. This is the simplest method of all apart from Kirchhoff law. So the current is found out by this formula. This is the 11th standard formula from our textbook itself. So the current is given by E equivalent upon R plus R equivalent, where equation for E equivalent is E2 R1 plus E2 E1 R2 upon R1 plus R2, and R equivalent is given by R1 R2 upon R1 plus R2. So first find these two values and then just simply substitute the value. First, let us find E equivalent. So E equivalent will be equal to E2 R1. E2 R1 means will be 1 into 1 plus E1 R2, 4 into 1 divided by R1 plus R2, that is 1 plus 1. So this will be equal to 5 by 2. Similarly, R equivalent, that will be 1 into 1 upon 1 plus 1. So that will be 1 by 2. Now just simply substitute these values over here. So current will be equal to 5 by 2 upon 2 plus 1 by 2. So this will be equal to 5 by 2 upon 2 plus 1 by 2 is also 5 by 2. So that is 1 ampere. So within 2 minutes, you can get the answer. Up till now, if you use Kirchhoff law, in this much time, you should have only drawn the circuit diagram. So it's a lengthy method if you use Kirchhoff law. Nevertheless, those who find it easy, they can use Kirchhoff law and solve this. Even in our textbook, example 9.2 is an example which is solved using Kirchhoff law. This is an alternative method which we can use to solve this question. So the answer is 1 ampere. The same question is next sum. Same, only the values are changed. So I can write first voltage is given 1.5 volt, which is having an internal resistance of 2. Second is given as 2 volt. E2 is given as 2 volt. The internal resistance for the first case is given as 1 ohm. The internal resistance for second one is given as 2 ohm. Capital R is 5 ohm. Again, find the value of current. So I know the formula, current equal to E equivalent upon R plus R equivalent. This is the formula for the current. You should know what is E equivalent. E equivalent is E2 R1 plus E1 R2 upon R1 plus R2, and R equivalent is R1 R2 upon R1 plus R2. In electric current through conductors chapter, if you see in 11th standard textbook, you have this formula for cells in parallel combinations. This formula is only applicable when you use cells in parallel, because this is a formula for cells in parallel. So just substitute the value. So E equivalent will be equal to 2 into 1 plus 1.5 into 2 upon 1 plus 2. So this will be 3 plus 2, that is 5 by 3 This will be E equivalent. R equivalent will be equal to 1 into 2 upon 1 plus 2. So that will be equal to 2 upon 3. So current will be equal to 5 upon 3 divided by 5 plus 2 upon 3. So when you solve this, you get the answer as 5 by 17 ampere. The answer is 5 by 17. A voltmeter has a resistance of 30 ohm. So R is given, 30 ohm is the voltmeter resistance. What will be its reading? Whenever there has been asked what will be its reading, reading means voltmeter reading, that is V is been asked, V value of voltage. When it is connected across an EMF, E is given 2 volt and internal resistance small r is given as 10 ohm. So we know that voltage V equal to IR, and the current formula is given by E upon R plus R into capital R. The formula for current is this. It is similar to what we have used back. I equal to E upon R plus small r. It is same. So E upon R plus R into capital R. So V equal to E is 2 upon 30 plus 10 into 30. So this will be 2 upon 40 into 30. So this will get cancelled, 1, 2, and this will be 1.5. So the answer is 1.5 volt for this particular question. That's it. Next. Very important sum. A set of 3 coils having resistance 10, 12, and 15 ohm are connected in parallel. Let us draw a diagrammatic representation. I'll just draw one circuit diagram. There are 3 resistances. One is 10, one is 12, and one is 15. Okay. I'm not putting the labeling. Let 10, 15, and 12, 10, 12, and 15. These are the 3 resistances connected in parallel. So this is a parallel combination. This combination is connected in series with the series combination of the 3 coils of same resistance. This is very confusing statement. I'll break down the words. This combination means this particular circuit diagram which I have drawn, 10, 12, and 15, which is in parallel. This particular combination is connected in series. Leave away this sentence. With a series combination of 3 coils of same resistance. So 3 coils are there which are of these same resistance, 10, 12, and 15. Iska series combination. Now first draw the series combination of these 3. So let us assume this is 10, this is 12, this is 15. Now these two combinations, now the word which I told you to leave away, that was in series, connected in series. Connected in series, so just join these 2 lines. That's it. Just join these 2 particular circuits in series. That completes your diagram. Now reread the question if you want. The combination is connected in a series. So this is a series diagram with a series combination of the 3 coils of same resistance. So this parallel combination which I have drawn, this parallel combination is connected with this series combination with the series combination. This is series. They both are connected together. That is a series combination. Right? This is your circuit diagram. Calculate the total resistance and current through the circuit if the battery is 4.1 volt. Okay, first find the value of resistance. That is important. So on solving the diagram, you will have to draw the diagram. So on solving for parallel combination first, for parallel combination, I can write R1 upon Rp will be equal to 1 upon 10 plus 1 upon 12 plus 1 upon 15. The LCM is 60 for this. This will be 6 plus 5 plus 4. This will be 15 upon 60. That will be 1 by 4. So therefore, how much is Rp? Rp is 4 ohm. Rp means the parallel combination. Means answer for this combination is 4 ohm. Means even if I remove this combination, instead of this combination, now I apply a 4 ohm resistor. Now what will be my circuit diagram? My circuit diagram will be 4 resistances in series. That is 4, 10, 12, 15. What is this 4? This 4 is the answer of 10, 12, 15 in parallel. I have solved first parallel. Instead of that 10, 12, and 15 in parallel, I remove that 3 resistance. I'll just put one 4 ohm resistance instead of that. Now these 4 are in series. So total resistance will be equal to R will be equal to Rp plus 10 plus 12 plus 15. So R will be equal to 4 plus 10 plus 12 plus 15. That will be 41 ohms. What do I supposed to find? I am supposed to find the total resistance. I have found out the total resistance. This is R and current. So I have V equal to IR. So I will be equal to V by R. V is given to me as 4.1 in the question. 4.1 divided by 41, that is 1 by 10. 1 by 10 means 0.1 ampere. A potentiometer is a wire of length 1.5 meter. So potentiometer wire length is given, L is given 1.5 meter, and resistance capital R of 10 ohm. It is connected in series with a cell of EMF is given 4 volt and internal resistance R is given as 5 ohm. Calculate the potential drop per centimeter of the wire. Potential drop per centimeter. Now potential drop per centimeter means K equal to V by L. Potential drop per centimeter you need to convert. K equal to V by L. That is our formula for potential gradient. So K equal to V, instead of V I will write IR divided by L, and I is equal to E upon R plus R into capital R upon capital L. So this is my final formula. E upon R plus R into capital R upon L. But I need to convert it into centimeter. So 1.5 meter means 150 centimeter. I have to take it to centimeter. In the question, it says potential drop per centimeter. So length used will be in 150 centimeter. So just find this value of K. E upon R plus R. E value is 4 upon R value is 10 plus 5 into capital R is 10 divided by 1. So just solve this. You get the answer as 1.78 into 10 raised to minus 2 volt per centimeter. This will be your answer. When two cells of EMF E1 and E2 are connected in series so as to assist each other, whenever the cells are set to assist each other, the EMFs are added. So the potentiometer length is found to be 2.7 centimeter. So first length is given 2.7 meter. When cells are connected to oppose each other, in that case, it is found to be 0.3 meter. So second length is given 0.3 meter. Compare the EMF. Compare the EMF E1 and E2. Now we have a formula. E1 upon E2, when cells are set to assist and oppose each other, E1 upon E2 equal to L1 plus L2 upon L1 minus L2. That's it. Very small formula, very small sum. So therefore, I can say E1 upon E2 will be equal to 2.7 plus 0.3 upon 2.7 minus 0.3. So this will be 3 upon 2.4. So when you solve this, you get this as 1.25. 1.25 is your answer. Next. A EMF of a cell is balanced by a length of 120 centimeter. So length is given, say L1 is given 120 centimeter, converted to meter, 1.2 meters of a potentiometer wire. When the cell is shunted by a resistance of 10 ohm, capital R is given 10 ohm, the balancing length is reduced by 20 centimeter. Reduced by 20 means initially it was 120. Now it is reduced by 20 means 120 minus 20, that will be 100 centimeter, that is 1 meter. Reduced by 20 means whatever value there was in initial, you have to subtract the 20 centimeter from that. So initial that was 120 centimeter. Now you subtract 20, 120 minus 20 is 100. If it was said that the balancing length is reduced to 20 centimeter, so L2 would have been 20. There is a difference between by and 2. Find the internal distance small r. So internal distance of a cell capital R, L1 upon L2 minus 1. Simple formula. All values are given to us. Just substitute the value. 10, 1.2 upon 1 minus 1. So R will be equal to 10 into 1.2 minus 1. That is 10 into 0.2. So that is 2 ohm. That is our answer. 2 ohm. A potential drop per unit length along the wire is 5 into 10 to the power minus 3 volt per meter. So this is K, this is V by L is given 5 into 10 raised to minus 3 volt per meter. With the EF, if the EMF of a cell balances against a length of 216 centimeters, so length is given 216 centimeter, that can be written as 2.16 meter. Then find the EMF of the length. Okay. So I know that EMF equal to K into L by principle of potentiometer. So EMF can be written as K value 5 into 10 raised to minus 3, length value that is 2.16. So just multiply the two numbers. You get this as 0.0108, 0.0108 volt. That is your answer. A resistance of a potentiometer wire is 8 ohm. Capital R is given as 8 ohm. And its length capital L is given 8 meters. A resistance box and a 2 volt battery is given to us. EMF is given as 2 volt, are connected in series with it. With it. What should be the resistance in the box. The resistance in the box is a rheostat resistance. I'm denoting it by Re. If it decide to have a potential drop K of 1 microvolt per millimeter. Microvolt means 10 to the power minus 6. Millimeter means 10 to the power minus 3. Minus 3 will go in the numerator. It will become plus 3. Plus 3 minus 6 will be 1 into 10 to the power minus 3 volt per meter. That is the K value. Now we know that K equal to V by L. This is our formula. We will use the same formula, but here there are some changes. K will be equal to V will be IR upon L. I is written on E plus R plus there is one more resistance, that is Re. I did not write this Re resistance in earlier sums, but in actual formula there is capital R is the external resistance, small r is the internal resistance, Re is the rheostat resistance. That is what asked over here. In the previous sum, there was nowhere mentioned about the external resistance, so I neglected it and I assumed it is to be 0. So hence in previous sums, wherever I use this formula, I did not write Re because it was not mentioned and you will assume it as 0. In this sum, if you see, I have been given capital R, I have been asked Re, but small r is not given, so you will assume small r as 0 here. The data which is not given to you, you will be assuming it as a 0 into capital R divided by L. So therefore, K value is given to us. K value in LHS is given to us as 1 into 10 raised to minus 3 equal to epsilon value is 2 upon 8 plus 0 plus Re into 8 upon 8. Len value is also 8. So this will get cancelled. 1. So 1 into 10 raised to minus 3 equal to 2 upon 8 plus Re. Take 8 plus Re to left side. So 8 plus Re will be equal to 2 upon 1 into 10 raised to minus 3. 10 raised to minus 3, when it will go up, it will become 10 raised to plus 3. 2 into 10 raised to 3 means 2000. I need to find the value of Re. So Re will be equal to 2000 minus 8, that is 1992 ohm. And that is your answer. Very, very important Kirchhoff law application based sum. There are some changes in the circuit diagram. I want all of you to please look at this. So here this is I2, this is I2, this is I2, this is also I2, this is also I2. Here this is I1, this is I minus I1, this is I1 minus I2, this is I minus I2, this is I minus I1. The EMF is 10 volt. These are the changes to be made in a textbook. Some textbook it might not be mentioned. So if it is not mentioned, you have to make that changes. In each branch there is a current which I had mentioned, and the EMF is given as 10 volt. This is given to us. The question says each resistor is of 10 ohm. All values of resistance are of 10 ohm. So using Kirchhoff law, we need to find the equivalent resistance between terminal A and B. A little lengthy sum, not little, I guess it is more lengthy sum to solve. So first, just make the corrections in your textbook and wherever you are writing. Let us consider loop by loop and solve this particular question. First, I will assume the upper loop which is given to me, GABHG. So using Kirchhoff law to solve this sum. Using Kirchhoff's law, first loop GABHG. GABHG. So you can see over here GABHG is mentioned here. I have labeled this terminal as X. Even that is not mentioned in many books. I've just labeled it from our case. So just write that also X. So GABHG using Kirchhoff law. So when you use Kirchhoff law, you get minus I2 into 10. Please remember each resistance is of 10 ohm. Minus I2 into 10. Minus I2 into 10 once again. Then plus I minus I2 into 10 plus I1 minus I2 into 10 is equal to 0. So this is my first equation. I'll open up the brackets. Minus 10I2 minus 10I2 plus 10I minus 10I2 plus 10I1 minus 10I2 equal to 0. If I take I2 terms together, I see there are 4 terms of I2. So that will be minus 40I2 plus 10I plus 10I1 equal to 0 divided by 10. So I get this minus 4I2 plus I plus I1 equal to 0. From here, find the value of I1. So I can write I1 equal to 4I2 minus I. This is my first equation. If you go to the next loop, which I have, second loop I will take is a lower loop, FGHXF. FGHXF. So use Kirchhoff law in loop. FGHFX. So if you see that now very carefully, I get minus 10I1 minus I1 minus I2 into 10. You have to please look at the diagram. I'm looking at the diagram. Alongside, I have my textbook with me. So look at the diagram and apply Kirchhoff law. I minus I1 into 10 plus I minus I1 into 10 will be equal to 0. Take I1 terms together, open the brackets, take I1 terms together. So you get over here, first open the brackets, minus 10I1, minus 10I1, minus minus plus 10I2, plus 10I, minus 10I1, and plus 10I, minus 10I1 equal to 0. Take I1 terms together. Here there are more I1 terms. So this will be minus 40I1 plus 20I. There are two I terms also. So plus 20I plus 10I2. Yeah, there is here one I2 term also, that is equal to 0. So divided by 10. So minus 4I1 plus 2I plus I2 equal to 0. From here you find the value of I. So I will be equal to 4I1 minus I2 upon 2. Just rearrange the terms and find the value of I. It is second equation. Now we'll use the third loop that we have. Using third loop, that is loop. The third loop which you have in the question is this one. From E, you will start from E. E, F, X, H, E, F, X, H, and this full D, E. You'll come back from D to E. This full loop you will have to use. Okay. So suppose if I start from F, loop F, X, that loop I'm using. Loop F, X, H, B, C, D, E, F. That loop. The last loop which you can see, the zigzag loop. In that, when you apply the Kirchhoff voltage law, you get minus I minus I1 into 10 minus I minus I1 into 10. You have to please look at the textbook to see what I'm writing. Minus I minus I2 into 10 equal to 0. Only three terms. Okay, there is EMF also. There is EMF also. For that case, it will be plus 10 in the LHS part because EMF is also there. Here I made plus 10, then equal to 0. Plus 10 equal to 0. Just open the brackets. Minus 10I plus 10I1 minus 10I plus 10I1 minus 10I plus 10I2 plus 10 equal to 0. Now from here, what do you see? There are more I terms. So therefore, you can take minus 30I plus 20I1 plus 10I2 plus 10 equal to 0. From here, find the value of I2 divided by 10. First, you divided by 10. So you get minus 3I plus 2I1 plus I2 plus 1 equal to 0. And from here, you find the value of I2. So I2 will be equal to 3I 3I minus 2I1 minus 1. That will be the value of I2. Give it as equation 3. 3I minus 2I1 minus 1. That will be the value of equation 3. So we have found from all the three loops. Now we need to substitute few terms. So we have this second equation at the back. Substitute this 2 equation, the value of I in this equation 2, the value of I which we have got in this equation. This equation I is need to be substituted in this term, in equation 1 over here, in the first term. So let us substitute the values, and similarly I'll have to substitute I2 also. Let us do one by one. First substitute, put 2 in 1. Substitute 2 in 1. So we get that I1 will be equal to 4I2 minus 4I1 minus I2 upon 2. So just solve this equation. So I1 will be equal to 4I2 minus just open the bracket, 4i1 upon 2 plus i2 upon 2. Just rearrange the terms and solve. I hope that will be easier for you to do and get i1 value. Just solve the RHS part and get the i1 value. Then i1 will be equal to 3 by 2 i2. I'm not solving now each and every step. It is already a lengthier sum. I expect at least this much you can solve. Only the right hand side you have to solve. You get I1 equal to 3 by 2 I2. Give this as equation 4. Similarly, what do you do? Substitute equation 4 in 3. Put this equation 4 in 3 in previous equation over here. So here I can find the value of I1. I will substitute the value of I1. So you get equation 3 mein you have I2 equal to 3i minus 2 times I1 value, that is 3 by 2 I2 minus 1. So again, just solve this equation. On solving this equation, you get I2. I2 equal to 3i minus 1 by 4. This is very simple to solve. At least you can solve the RHS part. Only you need to solve the RHS part and you will get this equation. 3i minus 1 by 4 will be your particular answer in this case. Give us equation 5. From this 4 and 5, if you see it very carefully, the total current I is a sum of I1 and I2. There are two currents only. So total current I will be equal to I1 plus I2. So substitute the value of I1 and I2. I1 value 3 by 2 I2 and I2 value 3I minus 1 by 4. So these two values I have to substitute. So this will be written as I will be equal to 3 by 2 I2 plus I2 value is I2 value can be written as 3i minus 1 by 4, or just I can simply put here I2, and if I cross multiply this, so this I can get this as 3 by 2 3 by 2 I2 plus I2. Just solve this 3 by 2 I2 plus I2. So when you solve this, you get this 5 by 2 I2, and now put the value of I2. 5 by 2 times I2 value over here, 3i minus 1 by 4. 3i minus 1 by 4. So just solve the LHS and RHS part. So I will be equal to 5 by 2, 3i minus 1 by 4. So this I can write 5 3s are 15i minus 5 upon 8. Take that 8 at that side. So I can write 8i equal to 15i minus 5. So 15i I minus 8i equal to 5, and therefore 15i minus 8i 7i equal to 5. So I can be equal to 5 by 7 ampere. This is just the current that we have got. We also need to find the resistance. So we have V equal to IR, and from here I can say R will be equal to V by I, and V value I have already given you in the question. It is not mentioned in the textbook, but V should be taken as 10. So 10 upon 5 by 7. 7 will go up if you see. So 10 into 7 upon 5. So this will be 5 ones are 5 twos are. This will be 2 into 7, that is 14 ohm. And that is your answer, final answer. A little lengthy sum, not little, but much lengthier sum. But yeah, one application of Kirchhoff law of this particular chapter. So here we end with the current electricity chapter numericals.